All right. Well, thank you very much for the introduction. The first company I started out of MIT was in 2002, and it was in distributed power generation. And I got a chance to work with a whole range of technologies, but focusing on wind power because that's where the economics made sense. And that industry scaled from about 500 million to 15 billion per year in the US in about 6 years. So it was a really exciting time to be in that industry. And the first wind project I developed was actually the Munnsville wind project right near Madison, New York. So further east from Rochester, but I spent a lot of time driving around upstate New York and also developed the wind project that's on Wolf Island on the right near the border with Canada in Kingston. So it's a pleasure to be here. I really appreciate the opportunity to speak with everyone here. And I thought it would be helpful to just mention that I wear several hats, and that today is really my thoughts and how I'm thinking about things. But I'm pulling together pieces from a lot of different organizations, and I tried to make sure I sourced everything and provided links to everything. There's a lot of great resources here. You're more than welcome to follow through, ask me questions if you want to connect with any of them. But I did want to set the stage as a reminder of why this is important, and then really highlight that we're not moving fast enough. Get into some details on transportation as to why it takes so long to move. There's a lot of inertia in these really large systems, so it is hard for new technology to really move the needle. And then highlight the need for additional big ideas and how can we pursue things in parallel so we're not waiting for solar and batteries and wind to decarbonize everything. I mean, if we waited long enough, we could do that, but it's just going to take much longer than we have. So, and then finally, in order to move more quickly, I really want to show you some of the tools that we're working on that can really help accelerate innovation. So I'll finish with a little demo with some of the tools that are coming out of the Martin Trust Center. There's an organization called Probable Futures, and it's a really great website and organization that helps put things in perspective. So this is one of the important things that it's worth spending some time on is understanding this band of climate stability. So about 12,000 years ago, Earth's climate stabilized, and that's when humans around the world settled around the same time. And those settlements led to societies and governments and ultimately the economy that we have today. And it's important to note that we left that band of stability. That was 1.2 degrees C, and that was in 2021 time frame. You hear about 1.5 and 2 degrees C. Those are the targets in the Paris Accord, and even those numbers are no longer very attainable, in my opinion. The 1.5 degrees was surpassed over the last, I think it was in January or February this year. The 12-month running average exceeded 1.5, and right now we're about 1.65. It should come down with La Nina as El Nino changes. But the Paris Accord doesn't define the term average. So there are different perspectives as to what average we should use. And right now there are people, looking at 10 years average, 20-year average. But really it's not defined in the Paris Accord. And, I think something along the lines of an El Nino cycle, which is 3 to 7 years, is probably more appropriate. But just to give everyone some perspective on this, 1.5 is now in the rear view when you look at a 12-month average, and 2 degrees. I don't hold out much hope of staying below there, but I'll talk about some of the ways that maybe we can do that. So why is this important? Why are we here? It's about the impacts that climate change are having for everybody, and it's with 2023 and all the one event after another around the world. It's really hard to ignore at this point because it is happening pretty much everywhere. And this is an example I like to give because I was in a meeting. This was a board meeting at Woodwell where we were getting a science briefing from Dr. Francis about the weakening of the jet stream, how it dips down into Texas, and it's going to stay there for a week or two at a time. This was in early 2020. And about a year later, that exact event occurred. And the image that was in the Financial Times was almost the same image that was in her presentation. And that event led to around $100 billion of economic losses in Texas. The grid essentially failed. It was seconds away from complete collapse. Natural gas dropped. People were without power for weeks. Energy firms went bankrupt, and unfortunately, most unfortunately, people died. So these events are going to become more frequent, and climate science can tell us what's coming. Can't tell you exactly when, but it can give you a sense of what's coming where. And these tools are available. I mentioned probable futures earlier. So what does this mean for Rochester? Rochester is very, I would say, mild from a climate risk perspective. So most of the temperatures, extreme, you probably have to worry about some potential flooding. But I thought the one to highlight, which is one that's a risk in Massachusetts as well, is fire risk. And this is at 1 degree C. So this is recent history. There really isn't much of a risk now, and there really wasn't a risk before. But at 2 degrees C, it's a risk. It's a real risk for all of New York, all of Massachusetts, much of Canada. And that is something that should drive decision-making now. There are policies and actions that we should be taking now. And that's how we should be looking at this climate data and the climate modeling that's available. This is through the Probable Futures website. Anybody can go on there and zoom into wherever they're located. And there are different maps that you can choose. So I chose this one because I thought it was the starkest message for where you all are based. So we're making a lot of progress. So the pace of improvements in solar and wind, and most recently batteries and EVs is really astounding. And I've been fortunate enough to live through these cost curves and these market growth cycles and expansions over the last 20 plus years. And it's really amazing how quickly they're changing and how large these systems are now. I mean, we're talking about deployments of over 1 gigawatt now of wind and solar, over 2 gigawatts even if you add them together. This is as of 2020 in this date, but the pace of change from a deployment perspective is very, very exciting. And you are starting to see the emissions from the CO2 emissions from fossil fuel starting to look like they're tapering off and maybe come down. So it is important to note that we have record high deployment of solar and wind, but we still have record emissions from coal. And the climate doesn't care how much wind and solar you put on the grid; it cares what the emissions are. And if we're not reducing emissions, that's a real problem. Another thing that's important to note in this chart is that you see these dips that occur around the financial crisis and around COVID. Or to go back to the early 90s, you can see the collapse of the Russian economy. It shows how behavioral changes or non-technical deployment can have a massive impact, but it also shows how quickly things rebound. And I'll come back to that later. But it is important to see that things can change quickly, but it's usually pretty big and bad events that cause those changes. And looking forward, there's all sorts of projections. This is part of the IPCC report that came out in 2023, and they were still talking about limiting warming to 1.5, which I think is, again, not possible. And it just highlights how delayed these reports are. By the time they're published, they're years old, and the data is very old, and it's not, I think, as useful. For example, the models that are being included to drive these reports don't even include emissions from thawing permafrost. And we now know that is, I should say 82% of the models don't include any emissions from thawing permafrost. And the ones that do assume a very linear progression, which is not the case. It's about 3 or 4 times worse than the models that do have emissions from permafrost. So you can notice that the two pathways here to even limit to 2 degrees that's a massive change compared to that earlier chart. And we're on this kind of glide path of that red line, maybe it's still going up. Like the worst case scenario is still going up. So it is very hard to move this system. And a good example of that is looking at the United States. So these are emissions from the United States. This is specifically carbon dioxide. And you can see how US emissions actually peaked and have been declining for several years now, almost 20 years. And transportation is now the largest single source of emissions for the US. And the electric power industry was highly driven by a shift from coal to natural gas, as well as more deployment of renewables, and the overall load growth kind of maintained. It didn't increase significantly, so there wasn't a lot of new demand in this time period because of primarily efficiency improvements. So a combination of things led to reduced emissions. Transportation also peaked around the 2005 to 2007 timeframe, and that's also mainly been driven by efficiency improvements and higher fuel prices. So most of the demand going up until about 2005 was driven off of a $20 a barrel oil price, and it took a time for the system to get used to $50, $100 plus barrels of oil. So I'm going to talk to a little bit more of the transportation shift and why it's such a challenge, because you see again these massive growth in EVs as an example. So this is the global electric car stock. This is very encouraging. And it's also important to note that most of the demand globally and the supply globally is in China. I believe the number is around 60% of the global market for both production and demand of EVs. But the big challenge is that you have a massive installed base. So while these growth numbers are impressive, we're really still just starting to reduce the amount of internal combustion engine vehicles sold per year. And even if they were all EVs right now, it would take about 20 years to replace the entire fleet. There's 1.4 billion vehicles on the planet, and we're looking at a replacement rate of about 70% or 70 million a year. It's going to take a long time to ramp up the mining capabilities needed to get the materials, the battery production capabilities to produce the batteries. We're making a lot of progress. It's going to happen, but it's going to take decades really to drastically reduce these emissions. It's important to note that I think that EVs are really going to be the primary driver for passenger vehicles, smaller vehicles. But as you get up into road freight and aviation and shipping, it gets complicated. There's all sorts of different ways of solving these problems. But again, each one of them takes a long time. So for Class 8 trucking is a good example. There are new solutions available. Tesla has their semi, which is now on the road with customers. There are other providers of EV trucks, Daimler, although everybody is offering EV trucks, but supply is still limited. There's still not a huge amount of these vehicles coming on the road, and charging infrastructure is very challenging. Each one of these vehicles, when it's charging, can draw a megawatt of power or more. For perspective, 5 megawatts, that's about the amount of power that a large sports stadium would use, or building like the Empire State Building. So trying to plug in a lot of these vehicles at the same place is a real challenge. One of the companies I'm working on helps leverage existing infrastructure like arenas that have a lot of capacity to charge that don't need it most of the time. So you can think of underutilized grid infrastructure as a solution. Another a way of reducing these emissions is with alternative fuels. This has had a bit of a checkered past and a challenge, but this is a fast way of changing over engines, even modifying engines. Fueling infrastructure can still be a challenge, but the other question is, what's the feedstock? Where's the alternative fuel coming from? And one note, especially around hydrogen, and is the emergence of geological hydrogen. This is a new category. I remember in 2008 when I was in North Dakota, I was developing a wind project, and someone mentioned shale oil, and I thought, I didn't think it was possible at the time, and the change that's had is unbelievable. So I would keep an eye out on geological hydrogen. There's some serious investors that are looking into that space. And that's the kind of thing that could drastically change the landscape, because the economics are cheaper than even natural gas in some cases. So this is an area to keep an eye out for. So we've talked about a couple of the technical ways of reducing emissions from transportation. But when the war in Ukraine broke out, the IEA posted this 10-point plan for cutting oil production. And buying an EV was number 10 on the list. There's a lot of ways of reducing emissions, and a lot of these are behavioral. So I think it was carpooling is one of the largest ways of drastically reducing fuel consumption, or reducing speed limits, as we did in the 70s and 80s. So some people don't think that changing behavior can have a big deal, but here's an example of, this is a quote, this was the title of the article, a ridiculously simple idea to cut cargo ship emissions. Industry standard for these types of ship is to go as fast as possible to the port and then wait. So it's called sail fast, then wait. If you just slow down and arrive on time or closer to your actual scheduled unloading event, you can reduce emissions, in this case by 17% is what they were saying. That involves scheduling and coordinating with the port as well as the ship in a way that is not industry practice. So this is an example of a behavioral change and a system change that could have drastic effects very quickly. Another example of that is for aviation, a very, very hard problem to solve in terms of decarbonization. Planes have very hard, very, very dense energy needs. If you think of the amount of energy in a gallon of aviation fuel, it's hard to replace that with batteries. Although there are electric aircraft, smaller aircraft, I do think that regional aircraft will be a great application. The U.S. has a tremendous small regional airport network, and I think it would be a great way of leveraging that. But this is a totally different approach. So this is essentially trying to reduce the amount of contrails. And contrails is going to account for 35% of aviation's global warming. And by changing the altitude and the way that the planes are flying, you can actually reduce those contrails. And in a test that was done with Google, American Airlines, and Breakthrough Energy, they were able to modify flight patterns and actually reduce contrails by 54%. And the estimated cost of doing this was about $5 to $25 a ton of CO2 equivalent. Now, they're not reducing CO2 emissions. There actually may be some more emissions because fuel consumption can actually go up because they're changing different, flying at different altitudes or in different ways. But at the end of the day, the global warming impact is actually better. So it's a little counterintuitive, but the price point here is what's important, because a lot of the CO2 removal projects are in the tens, even hundreds of dollars a ton. And this could be one of the very quick ways of reducing a climate impact. So we've been talking about emissions, and the example I just gave brought up a different approach of reducing the amount of energy that's captured within the contrails. And so the real important chart that we should be focusing on is not the emissions, it's Earth's energy imbalance. And while the emissions from CO2 look like they were kind of flattening out, the Earth's energy imbalance is not. It is going up very rapidly, and it is not good. So what are the things we can do more quickly, and why is that so important? So the heat is what kills. This is the bottom left here. This image is from a report that Woodwell did, which was in McKinsey's climate risk report. This is one of the most popular reports ever published by McKinsey. And it really highlights that over the next 30 years or so, in this area, in northeastern India, there's going to be about 1 billion people exposed to lethal heat waves. And for those of you who have not read The Ministry for the Future, I suggest you read it. Kind of plays out what this scenario could look like. Very, very scary situation. And as I mentioned earlier, climate modeling can help us identify these locations and the types of events that are going to happen. And so as with Texas, these types of events are going to happen. And what can we do about it? This is a specific climate risk report that Woodwell did for the DRC. Woodwell has done several reports for even cities and towns, not just countries. So that could be something that Rochester looks into, is getting a climate risk report. But what do we do about this? There are solutions. This is a nonprofit called NEAR, and they are layering essentially a reflective material onto, in this case, a corrugated tin roof house, and it changes the albedo and it reflects energy back. So it actually, in normal operating conditions, can reduce the temperature by 7 degrees C, which is a lifestyle improvement in most cases. Better sleeping, better lifestyle. But in extreme heat events, that's the difference between life and death. And that's what's coming, and that's what we need to prepare for. We need to start doing things like this. We also need other big levers that we can pull very quickly that don't require massive amounts of technology. And just stopping deforestation is one of the tools in the toolbox. Deforestation, if it was a country, would be the third largest emitter. So we have to stop deforestation, and then a company called Momback is actually leading in terms of reforestation. A lot of these projects have gotten critical press over the last couple of years, but Microsoft just did a $150 million contract with Momback at the end of last year, and they recently announced another project. And that was a direct deal where Microsoft went through and assessed and decided to move forward on the project after about 2 years of diligence. So very, very thorough. Another big category is methane. Methane emissions are short-lived in the atmosphere, about 12 years. But the lifetime of the emissions don't really matter if the global concentrations are going up. And the global concentrations are going up at a very rapid pace. Methane is about 86 times more potent than CO2 over the course of 20 years. And I do think that that's the time frame that matters, 20 to 50 years. And these are the types of things that we should be focused on. In the long term, 50 years to 1,000 years, we have so many alternative solutions coming. Fusion, more small modular reactors. There's more wind and solar. I'm not concerned about the long term. I think we'll solve that problem. But can we buy ourselves some time in the coming years and get there where we can actually decarbonize? And so there's some other solutions. Moxair is a company out of MIT, out of Desiree Plach's lab, that has a proprietary catalyst that can reduce methane emissions from sources that are too dilute to flare. So here we show a cattle feedlot. It can also work for vented coal mines. And just for disclosure, I'm on the board. I just joined the board, and I do plan on investing in this company. It's a great one of the great solutions coming out of MIT. And then there are others. This is on the more I would say early concepts, but this is essentially trying to accelerate the natural process that decays methane. So just like companies are removing CO2 from the atmosphere, you can accelerate the decay of methane. And Blue Dot Change is one of those companies that's trying to add a system to ships that would reduce methane emissions as they're doing their normal voyages. This is essentially atmospheric chemistry. It obviously comes with a lot of risks, so it needs to be vetted and assessed. Unfortunately, there are organizations that are doing this. Ocean Visions is a network of leading organizations from around the world. MIT is a partner of it. PUI and several other global programs with ocean science. Their focus is reducing emissions, removing pollution, repairing ecosystems, and then reaching people. And they have a great roadmap for the various ocean-based carbon dioxide removal solutions. I suggest you look at the website if you want to learn more about those. And there is a report coming soon about Arctic ice preservation. This would be an example of trying to address a specific challenge you have. The poles are warming faster, about 4 times faster now than the average temperature. So the average temperature goes up by 2 degrees C, 8 degrees C in the Arctic. And we're seeing significant ice loss. Just recently in Antarctica, there was the equivalent of several Texas's worth of ice that was missing compared to the previous year. And that equals several gigatons worth of carbon. If you look at the energy that was getting reflected back is now getting absorbed by the dark ocean, which has a darker albedo and absorbs more of that energy. And there is another organization, Spark Climate Solution, that is doing some cutting edge analysis and research about the pathways for methane reduction. So these are some great organizations that are trying to help identify the research that's needed and supporting organizations that are trying to address these issues. So again, from Probable Futures, if you think about the economy that we have today, these systems that we have today, it's really all based on a stable climate. And that stable climate is already gone. So that is causing a lot of uncertainty, a lot of disruption within our systems, our societies. And we really need to identify what are the ways that we can reduce emissions, remove emissions, and then add some stability to that system, add some stability through resilience in our communities, adaptation, manage retreat in areas where we know that we no longer should be building, and ultimately climate interventions to try and buy some time. And that last point is a very sensitive one. It's something that we really shouldn't have to do. And it's a real question of when do we do that? Should we do it? We shouldn't, but everything I think that we talked about is already geoengineering. I mean, if you're emitting, if you're driving a car, you're flying a plane, you're emitting emissions, that's essentially geoengineering. I mean, we know it's in the wrong direction. So I thought this was a very simple chart to finish with. We need to aggressively reduce emissions. That's what everybody's focused on. We can also remove emissions, and then climate interventions is a key way of buying us some time. And it's a question as to what degree is this boundary? Is that 1.2? Is that 1.5? Is it 2 degrees? And I know that I'm out of time here, but I do have a short little demo that I want to walk through because I think it's one of the more exciting things going on. And I've been very fortunate to have been teaching the Climate and Energy Ventures course since 2008 and seeing how fast innovations are coming and the pace is really increasing. And I do think that AI deployed in the right way is really going to help us as a society deploy more solutions more quickly. And so I'm going to share a little tool that is in development. It's not fully released yet, but it is definitely pretty exciting. So the Martin Trust Center for MIT Entrepreneurship has a system called Orbit, which helps students navigate the 60 plus courses on entrepreneurship. So here's an idea for starting a company. I want to start an energy storage development company. And so I'm going to submit that. And Bill Aulette wrote a book called 24 Steps. It's discipline entrepreneurship. And here we got 0 of 24 steps completed. Here are the 24 steps. These might look familiar if you've ever started a company or gone through this process, but market segmentation is one of the first steps. So we go to that step. And just based off that prompt, right now it's generating a new market segmentation. So it's looking at residential, EV charging stations, commercial buildings, and this is all happening real time. And that took about 10 seconds. So this used to take weeks or months even for teams to do this type of work. And it's now done extremely quickly, which doesn't mean that the students only have to take the course for an hour. It means they're going to have more time to engage with their customers, with people that are the different segments that are recommended here, really pushing the assumptions and validating the assumption. And it's those iterations, I think, and that exposure to people in the market is critical. So this one's taking a little bit longer, but you get the point. Here we go. All right, there we go. All right, here we go. So it's going to give a little bit more detailed segmentation. This is for the beachhead market, and it's going to rank which one it thinks that we should pursue. Again, this is for the same categories, and it looks like it ranks utility scale energy storage is the number one for us to go after. And based on the technology, you can, try that or something else. So that is the, let's see here. I'm going to do one more real quick. So let's do an energy storage company. And it's going to be in Massachusetts. And so this one is that previous tool I showed you is general for entrepreneurship. And what we're doing is we're adding more tools that are going to be built on top of that are specific to energy and climate solutions. And in this case, what we're doing is we're looking at what are the relevant regulations that your company would have to learn about and follow if you're starting an energy storage company in Massachusetts. And so each one of these is a relevant document. You can then scroll through and see which ones are appropriate for your company. And the way that we're setting this up, the students can also add a document or a resource if they find something. So if they're doing a deep dive on a specific market segment and they found a resource, that can be added to the tool and make it better. There's other ones like this for incentives, so identifying the incentives that are relevant to the company. And you can envision how these will all feed back into each other. So your beachhead market is going to be influenced by the incentives, right? So like a certain state is going to be more attractive than another state, or the regulations. And that was how the wind industry played out in the US, with certain states that had renewable portfolio standards. Like Texas, for example, was an early state with a renewable portfolio standard. That's one of the areas where wind really took off. So really appreciate the time. Look forward to jumping into questions, and want to pass it back to Jim, or however you want to host.
Yeah, great. Thank you, Todd. Attendees, you can, if you have any questions, you can go ahead and enter them into the chat, or just take yourself off mute and ask your question directly. So I'll start with one, Todd. You mentioned that you're teaching a course on energy entrepreneurship. What would you say is the business climate or the investment climate like these days? I mean, is it clear to you that the investment community is getting behind a lot of these initiatives? Or is there still a reluctance and, kind of a feeling of, going after tried and true oil and gas types of investments?
There was a tremendous amount of capital raised over the last 4 or 5 years for funds specifically looking at call it energy transition, so more broad than wind and solar. So I mean, pretty much everything has an investor out there at this point. There's some challenges for the earlier stage segments, not necessarily companies, but if you're in a sector that is not clear as an emerging winner, it can be more challenging. But when I first started raising funds in 2009, which was probably the dark days. That was right after the financial crisis, and a lot of the clean tech 1.0 investors that were investing before then really pulled back from the market. So I think we are seeing some investors pull back. A lot of companies or funds have capital, but they're going to be focusing it more on their existing investments. So a lot of companies are making sure their existing portfolio companies have funding, but there has been a general slowdown in the last year or so. But the amount of funds that are available, and the amount of capital, and the amount of organizations that are out there trying to fund everything from nonprofit research to academic research to competitions to startups, and then also infrastructure. I mean, there is plenty of money if you can provide a good financial return for an infrastructure investor. There's really an endless amount of money if you can get an IRR on your project that exceeds the cost of capital. And so that's the thing that we're trying to get people to focus in on, is identifying the sectors that are emerging. So it already happened with wind and solar and batteries. It's now starting to happen with things like green ammonia, with enhanced geothermal is a whole new sector that there's some companies that are really interesting, and that's leveraging existing fracking technology to do essentially engineered wells where you don't have to be traditionally geothermal has had very site-specific requirements, and here you can actually create your own reservoirs. There's companies that are doing that already today, so it's been amazing to see how fast new sectors are emerging. But again, it still takes a long time.
Hello, this is Lan. I not aware of any effort to modify the direction of the jet stream.
Can you try to repeat the question? It broke up a little bit.
Oh, okay. Are you aware of any effort to modify the direction of the jet stream?
Not intentionally. I don't think it's an intentional effort. I think what happens, you get a weakening of the jet stream, and that's why you get these dips. And so that's one of the things that's causing the change. And the reason you get that weakening is that you get the emissions are causing like insulation, and so you're reducing the temperature gradient in certain areas, and that causes the jet stream to essentially get out of place and dip down into Texas, and you get these wild swings that you've had in several occasions.
Okay, Todd, we have one that came in on chat. The question is, how do you see global politics influencing deployment of climate solutions? And what are the trends you're seeing there?
Yeah, that's a very good and complicated question. I was fortunate to go to COP28 as well as COP27. And there's tremendous amount of people working on the problem. But the consensus process that COP has to navigate makes it, and the UN has to navigate, makes it very, very difficult. There's members that can really drag the process out, and that's just a challenge with that structure. And so there are countries that are going to be significantly at risk, more so than others in terms of handling this transition. So I think you're going to start seeing countries that have that risk get more direct and more vocal. But at the end of the day, it's, the US, China, India, if we're not moving, if we're not changing, the problem isn't going to get solved. And so there's a smaller amount of countries that are going to be, really, really looked at to make the change necessary. Europe's already well on its way, but still has a big, climate debt. If you think about emissions, historical emissions, there's a different way of looking at the climate impact. Loss and damage was a big part of this recent COP, which is trying to help move funds from countries that have historically emitted a lot to countries that need support and effort. And I think that can be done in a way that is effective. If you look at emissions from 200 years ago, they've been heating the planet for 200 years compared to emissions from yesterday, right? So it's all tons of CO2 are not the same. And if you take that time into consideration, the U.S. is still by far the largest in terms of impact. So cumulative emissions are highest for the U.S., but also that time is a big piece of it. When you bring up European countries, Germany, England, so there's a need to more effectively transfer capital from those countries to projects like reforestation projects, in Brazil, in the DRC, and just stop deforestation. So there's definitely financial mechanisms that can effectively deploy capital. I don't think there's going to be a big global coordinated effort. I think it's going to be a lot more direct deals. I think we're seeing that already with the types of projects that Microsoft is doing. We saw something very similar, and I'm sorry this is a long answer, but it's an important question. There's a lot of lessons to be learned from what happened with renewable energy procurement. So a lot of corporates in the U.S. wanted to support clean energy. And when they first looked into it, there were renewable energy credits. These were there was a mechanism that was built by the RPSs for the various states. These are the renewable portfolio standards that created essentially like an offset that people could buy. But they didn't want that. They wanted to buy energy directly from the project. And that wasn't even that. They wanted to help support a new project. And that's incremental. That really, and that's how most of the corporate clean energy contracts have been developed. And so you've got Google using its balance sheet to help finance a wind project, essentially saying, we're going to buy energy from this project. You have to buy energy anyways. It's going to be over the next 10, 20 years. That's used to finance the project. We're going to see a lot more of that with these climate solutions. And we're already starting to see it with the ones that are low risk. So things like these reforestation projects. There are also some very expensive efforts that are more energy intensive, which I'm not as excited about because we need that clean energy to decarbonize our existing grid and infrastructure. So I think you're going to see companies have a real risk. Their climate impact is going to be valued at some point by shareholders. If you have two companies that are exactly the same, and one has a really big climate risk and the other one doesn't, the one with the big climate risk is going to be a riskier investment, and that's already happening. There are investors who are looking at climate risk of location, zip code analysis of every town and every city, and looking at the climate risk. And 7 years ago, it was not priced in there, but it hopefully it's starting to get priced in there. But this is where you have two communities that are exactly the same in terms of term and bond rating, and the pricing should be the same. But if one is a real climate risk for 30-year debt, there's a risk there. So it'll be forced on companies at some point. So Ershan has a question.
Yeah, thank you, Todd. That was a very interesting presentation, and I think this might be kind of related to that last question, but just coming at it from a different angle. As a product manager in the solar industry, I'm very interested in the impact of different supply chains on the climate crisis. And in particular, with a lot of competition in the solar industry coming from China, comparing these kind of more easily scalable, centralized supply chains where China is basically cornering the market, but they're allowing downstream stakeholders to scale up renewables faster. There is geopolitical risk there, obviously, but I think my question is more on the sustainability side. Do you have any thoughts on kind of the pros and cons of, potentially the ease of scalability of the centralized supply chain model? I mean, I see it with the battery industry as well, and potentially with renewables. Versus more decentralized, potentially more sustainable long-term solutions.
All right, there are lots of good points in there, and I'm going to try and pick out a couple of interesting ones and give some shorter answers this time. So, as far as the challenge with China controlling a lot of production, right now we've got a global climate crisis, and when you look at deploying solar in the U.S., for residential solar as an example, the cost of sales is more than the cost of panels. So let that sink in, right? So the money going to the sales organization is more than the panels. So, and then the rest of the money is going to be for the installation team and the financing the project. So we should be deploying solar as fast as we can in the U.S., regardless of where the panels come from. And if we want to build panels in the U.S., we should be looking at next-gen technologies. And we're actually making panels. There's a professor, I think he's one of the youngest professors ever at MIT, Tonio Buonasisi, but he likes to describe the way that we make silicon for panels as like how we used to make glass 400 years ago. And then we need to make panels or silicon for panels like we make glass today, which is a completely different process. And so that's an idea of like a completely new supply chain, totally new technology. Put a bunch of these plants in Texas where energy is cheap, and then you have competitive production, really competitive long term with China. So that's kind of an answer for that part of the question. The long supply chain is also really a good one, and I think that we all saw how fragile our economy is when COVID hit with these large supply chain issues. And so you're already starting to see a natural shift to more distributed and resilient supply chains. And there's a really good example. There's a company called Talus Ag. I'm an investor and an advisor in this company, but they make a containerized ammonia production facility. So it is about 4 shipping containers that you can ship anywhere in the world, plug into an off-grid solar project, and you have on-site farm-scale production of ammonia. About half of the food that the world is consuming right now is a result of ammonia fertilizer, which primarily comes from natural gas. So this would be an example of not only decarbonizing that source, but completely disrupting, in this case, their first project was in Kenya, disrupting a 10,000 kilometer supply chain to Kenya. Sorry, from Kenya to Russia. 40% of cost for that is transportation. So instead of shipping the product, they're shipping the factory. And it's a really cool model that they were developing anyways. And then when the IRA, the Inflation Reduction Act, passed, all of a sudden they're a green hydrogen play, right? So they're able to take green hydrogen and make ammonia. And so they basically have unlimited demand in the US and now have a 10-ton per day system and are rolling out projects in the US. So a couple different points there, that I tried to get. Is there anything else in your question you want me to answer, or is that kind of helpful?
No, that was helpful, yeah. And I fully agree about the next gen technologies for the US solar market.
Appreciate that. You mentioned batteries as well. I did want to highlight, there are a lot of different ways of solving the same problem. And there's a lot for batteries as an example, a lot of different chemistries, and a lot of the initial EV batteries where energy density was so key had a lot of cobalt in them. And when cobalt prices spiked, the industry shifted away, and now lithium iron phosphate, which some of the first technology was out of MIT with A123. That was bought by a Chinese company, and now most of the production is out of China. So there are ways of adjusting supply chains that happened in solar in 2008 when it used to be that computers were driving silicon production. That shifted, that we were short on production for a couple of years, and factories got built, and now we've got enough supply. So the supply chains energy is such a huge industry that it moves markets. When something works, for example, in the late 90s, so many natural gas fired power plants were built in the US that it drove the price of natural gas up. And then the price of natural gas goes up, and then the economics of wind makes sense. And so many wind projects were built in West Texas that the price of electricity goes negative when it's windy. It's like a giant water balloon. You push in here, it pops out there, and you just got to, keep trying to push the emissions down and get more solutions out there.
Thank you.
Hey, Todd, you mentioned Ministry of the Future, and I read that a few months ago. Ultimately, the first chapter, as you mentioned, was traumatic, and pretty believable, right? Based on what you showed us. But much of the rest of the book was pretty optimistic, the way the world kind of came together on, addressing things. And, the Ministry of the Future is sort of like the top organization. Are you as optimistic as, as some of those developments in the book?
I would say I'm optimistic in the long term and pessimistic in the short term. I think it's going to get a lot worse before it gets better. I think the book tried to show that with some of the bad events that caused people to finally start taking action at a meaningful scale. But I think we've got a lot of uncertainty right now, I think that Resilience and adaptation is a very good use of funds and the use of effort. And there are more and more firms that are focused on investing there.
Mm-hmm.
And, right now we've got certain states that are, removing any language associated with climate change to their regulations. And there was one state that made it illegal to use forward projections. You had to use 100-year historical storms when you're doing insurance, and that makes certain places uninsurable. And so you're going to, states are now stepping in, and Florida's stepping in with insurance. So is California. It's not just red states. I think Florida's red now, but it's California included, and you can't buy your way out of that problem. That's going to bankrupt. If you don't change that policy, it's going to bankrupt the state, because there are certain areas are just uninsurable the way that the markets are structured, and the insurance companies are leaving. So you're seeing insurance companies just leave states where the rules are no longer, they're trying to cap increases. So either insurance goes up 150% or there's no insurance. That's kind of what you're seeing.
Okay, I have another one. You go surfing on social media and you see a lot of misinformation, disinformation, and I'd say kind of climate change denial. What is, you deal with a lot of MIT students as, part of your class. Is everybody on board who, you talked with, or is that kind of a problem that you see as well?
So social media and the internet made a lot more voices available to a lot more people. But I think even traditional press, I think a good rule of thumb is that basically it doesn't matter who's writing it, anything. A third of it is right. A third of it might be kind of right, and a third of it's wrong. And the difference with social media is that people are more intentional about this. I think this happens unintentionally, but intentionally as well in traditional media sources. And I've just seen that over and over and over again. And that's just the way I think the way it is. So when you're reading any article, I don't care if it's the New York Times or anything, this stuff is very complicated. And even the experts, there's debate even amongst the experts. And that's one of the things that always causes this kind of, we'll wait. I mean, we know enough. The big difference is we know enough to take as much action as we can. The debates that are happening right now are around things that are, pretty scary. There was so climate models are unbelievably effective. One of the things that, if you had a financial model for an investor and it was like 55% of the time or 60% of the time, you're a millionaire or a billionaire. Climate models are 90+%. I mean, they're very, very good if you go back decades. But there's a little bit of background noise. Just make sure people are muted. So it's one of the debates that's going on now is the emissions from fossil fuels, from coal, from shipping had a lot of aerosols in the atmosphere that actually added a cooling effect. And so there's a cooling effect in addition to warming. And so there was a debate on how big is the warming force and how big is the cooling effect. And if the cooling effect is really big, it can mask a bigger warming effect. So you could have a small cooling effect and a small warming effect. And how big those two things are is still being debated. And the problem is as we reduce these emissions, as we decarbonize, we saw this drastically over the North Atlantic and parts of the ocean where there was a lot of shipping, where we basically reduced emissions in shipping in 2020, and you saw a drastic increase in temperatures in those areas because of it. So it's really these big questions. And another really big one is methane. Methane has been skyrocketing in the atmosphere, and the concentrations are going up. and there's it's not clear what's driving it. Oil and gas it accounts for about 11%. It's mainly other sources. It's a lot of it's ag, a lot of it's natural from wetlands, but there's a lot more coming from areas like permafrost. And so one of the questions around the concentration in the atmosphere is it could just be more methane emissions, right? There's more sources. Those can be from human sources and natural sources, although I wouldn't consider thawing permafrost natural. But it can also be the reduction of the atmosphere's ability to naturally reduce those emissions, those methane emissions. And the reason is that one possible reason, this is the kind of thing that's going on, is there's these mega forest fires. And those forest fires, in addition to emitting CO2, are emitting carbon monoxide. And that can actually kind of utilize the same mechanism, the same chemistry that's naturally reducing methane into CO2. And so if there's less of that, there's fewer hydroxyl radicals floating around up there, then because they're going to carbon monoxide, like that's a problem, right? So it just shows the reason that, wow, we really got to stop forest fires. And there's some reports that came out of Woodwell that the cost of reducing forest fires reduces CO2 emissions at the equivalent of like $12 a ton. So there's all sorts of things we can do that are a lot cheaper than sucking CO2 out of the air and sticking it in the ground for $500 a ton, which is, what some people are doing.
All right. Great. So Todd, we're just about out of time, but I'm going to ask you one final wrap-up question.
Okay.
And then we'll call it a night. So the question is, what would you like all of us to do? As many of us are MIT alums, many of us are retirees. What can we do to kind of aid the effort here?
I always love the question of what can we do to help. And for climate, I think the answer is easy. It's like you should be working in the climate industry. So if you're whatever job you have, you can apply your skills to climate. So if you're retired, you can volunteer. If you're a student, you can learn. Then you can get into reducing your own emissions and voting and changing your diet. I mean, there's a whole host of things you can do. I stopped eating cows a long time ago, or cattle a long time ago. It's about 10 times worse than everything else. So you don't have to be a vegetarian to stop eating beef. That's a big one. The other specific things, I mentioned probable futures. I suggest you go to the website, you look at what they have to offer and see how you can incorporate that into your own community. I think that's a really good resource. And then I highly suggest everybody get an open AI account, learn how to use AI tools. You should buy Ethan Mollick's book called Co-Intelligence. He is the person that MIT brought on for an hour lecture to lecture 150 MIT faculty on the impacts of AI on education and innovation. He's one of the best at communicating this information in a way that anybody can understand and apply to how they're living their lives. And it's really amazing how effective these tools are. And the world it'll take 20 years to, adjust to what's already available today, let alone the new technology that's coming. So
I'm typing that into the chat so we can all see it. So it was Co-Intelligence by
Ethan Mollick, and he's an MIT grad. He's also he's a professor at Wharton.
And last name is spelled
Mollick, I think.
Got it. All right.